What's up, notJust developers? Today we're actually gonna build the worst volume controls. I've got this idea a couple of weeks ago when I saw a tweet thread, and actually a bunch of developers, I think in 2017, competed to design and implement the worst volume control on web. I'm super late to this trend, like you couldn't be more late, but I thought like it's a great opportunity for us to see how we can do some of this volume control in React Native. And as you can see, there are a lot of hilarious ones. But yeah, we're gonna do that in React Native with Expo. And every dumb idea is actually an opportunity to learn something new. So today we're gonna work with some sensors data with Reanimated to make animated volume controls useless, but at least they will be beautiful and they will work well. For that, I'm gonna take advantage of Reanimated. We're gonna use Reanimated for it to add some animations, to spice it up a bit, and also what we are interested in is in a hook that allows us to run animations based on sensors. So if we look at the hooks here, there is this useAnimatedSensor that allows us to run animations based on the accelerometer, the gyroscope, gravity, rotation, and so on. The first one that I want to do is very similar to this one here. From this design, as we can see, like you are able to drag the box in order to make the slider move based on the gravity. This is the first one that I thought like, oh, it would be so nice to implement with the animator, because we can actually hook to the gravity sensor of a phone and basically move a phone in our hands in order to move the volume control. I wasn't the first one to think about that, because someone from Software Mansion already implemented exactly what I was thinking about. So shout out to Kakper. So yeah, that's what he did. And basically you're moving the phone in the hand, and this one changes the volume control. Let's have a look and try to implement it ourselves. So for that, first of all, we will need to install the Reanimated in our Expo application. Is it already installed by default? Actually, yeah, it's installed by default. Okay, perfect. Then we don't have to install anything. We can right away implement it. So let's go ahead and create a new one based on the template and call this one gravity. Let's navigate here to the gravity. We will also need the volume control from our basic one from index. So let's grab it from there as the slider like this. Okay, I will also need to run it on my physical device to see the changes. So the first things first, let's go ahead and import the useAnimatedSensor from React Native Reanimated. And based on this one, let's start working with it. I'm gonna open the documentation for animated sensor, and when we are working with it, maybe they provide them. Yeah, they provide an example. So here is the animated sensor type. So sensor equal useAnimatedSensor. Here we need to specify the type. They provide here sensor type. And the one that we are interested in is in the gravity. We want to know, based on how we hold the phone, where is the gravity pulling, on which axis. To have a look at that, we can define an animated style. We want to rotate our slider left and right based on this gravity. So for that, we need an animated style. So let's go ahead and grab it. Use animated style. So what I did is in our gravity.js file, we imported useAnimatedSensor from Reanimated and the sensor type. This is how we hooked into the gravity sensor. And the next step is, based on the sensor value, we're gonna create an animated style that is going to control how our slider looks on the screen. Before that, I want to check the sensor value. And this sensor value has X, Y, Z. Let me quickly render them here, X, Y, and Z. Let me open the application on the phone to be able to rotate it in the hand. Here we have it, gravity. useAnimated has to return an object. Yes, the hook useAnimated should return some style. So let's return an object. Let's go back to the gravity, and we right away see the changes. So if I'm gonna go ahead and rotate the phone in this direction, as you can see, the first value which represents the x-axis, changes the value of the gravity from -9 to 9 on the other direction. So that means that the rotation that we're looking for is the gravity that pulls on the x-axis. Okay, perfect. We're gonna only keep that one for now. And what should we do with that? Well, let's go ahead and rotate the slider that we see on the screen. So the style prop for rotation, we can rotate based with styles using a transform. And here in the transform, we can specify how we want to transform. We want to rotate on what? If I'm not mistaken, we're gonna rotate around the z-axis. So if I specify here 30°, nothing will change because we are not yet using this slider view style. What we have to do is to give it to the view that contains our slider. So let's go ahead and add it as an additional style here besides these static styles as the slider view style. Still, nothing is going to happen because this is a normal view, but in order to animate something, it should be an animated component. So let's import animated from React Native Reanimated, and animated contains animated view. So animated view. If I do here background color red, if I go into the gravity, yeah, make sure, okay, it works. So as you can see, the background color red we don't need, but the transform and rotate Z, if we provide here positive value, rotates in that direction. If we provide negative value, it rotates in the other direction. So what we're gonna do is actually we're gonna use the value from our sensor for this value. Let's do it like this, x degree. And I'm gonna connect my phone. Here it is. So now if I rotate the phone in my hand, as you can see, this bar rotates together with it. We can multiply this by 2 and this will increase the amount of a rotation if that's what we want. Save, and now it will rotate more, as you can see. That's the first part, and that's the easy part, to rotate based on where the gravity is pulling. The second part that will actually pull the value of the slider is going to be a bit more interesting. For that one, we're gonna need shared value that is going to represent our volume. So let's import use shared value, and based on this value, we're gonna be able to drive like the position, the animation of this slider. So let's go ahead and do shared volume equal use shared value. We're gonna start with, I don't know, 0 maybe. Now we need to hook the value of our slider, this value, to our shared value that we define here. We can no longer work with state here because value of this variable is going to be controlled and updated based on the sensor on the UI thread. So on this thread, we should work with shared values to take advantage of performance benefits. That's why instead of working with a volume and set volume, which is a React state, we're gonna work with a shared volume, which is a shared value. And this one can be accessed both from the JavaScript thread and from the UI thread. So our next goal is to send that value here to the slider. To do that, as I said in the previous step, we need to make the component an animated component, like we did here with a view, animated view. The problem is that we cannot, animated doesn't have a slider. Slider is not a primitive React Native component, slider is a custom component. But it's okay because we can create using create animated component. Now animated slider equal create animated component, and we pass there a slider. And define is not a function. Shouldn't be, is it animated dot create animated component? Yes, that's right. So as I was saying, it's the same like slider, but now we are allowed to animate this slider. Previously, we saw how we can animate the style using the useAnimated style. Now, the problem is that in our situation, we don't want to animate the style, we want to animate a property, the property value of this slider. So how can we do that? We can do that by using the hook useAnimatedProp. So let's go ahead and import, first of all, useAnimatedProp, useAnimatedProps, and define here the slider props equal useAnimatedProps. And here, what we want to return is we want to return the value prop, which should be equal to the shared volume dot value. Now, when shared volume dot value changes, it will automatically update these slider props. And the last thing is to send this to the animated prop, slider props, and to comment out the value. Okay, what do we have now? Will it actually change if I do, I don't know, sensor.value.x? Will something change here? I should go to the gravity. As you can see, it's already working. Something is happening there because we mapped the value to the sensor value. So when we are moving into that direction, it's going to be like maximum. If we're moving that direction, it's going to be minimum. But what actually we want to do is we actually want to simulate a bit of a physics, and we want to accelerate in one direction when we are moving in that direction, and so on. So for that reason, we're going to move back to mapping the value to the shared volume value, and now nothing will happen because we are not updating anywhere this shared volume. Where do we want to update? Well, we want to update for every frame. Every frame that we update the UI, we want to calculate where should be the volume based on the gravity. Should it be more to the right, more to the left, and so on. To implement this kind of frame-based calculations and animations, we will use the useFrame callback. This useFrame callback, let's do it here, useFrame callback. The callback will contain the frame info, and we can do calculations here. So for example, we can console log frame info, and you're gonna see what information it has. I think I need to stop it so we can focus on one of them. Let's remove it. And we see the values are time since first frame, time since previous frame, timestamp, and so on. So what we are interested in is in this time since previous frame to know the delta time, like how much time should we consider for updating. Because if we are moving, for example, 1 meter per second, and 1 second passed, we want to move the ball 1 meter to the right. That's how physics works. If only half a second passed, we're gonna divide the speed by that number, and we're gonna get half of a speed. What we want to get from here is the delta time, and the delta time is gonna come from frame info dot time since previous frame. For the first frame, it's gonna be null. So let's check if it's null. Let's stop here, return. Otherwise, I want to update the shared volume value. I want to move it just a bit in the direction of where the gravity pulls. The gravity pulls into this sensor.sensor.value.x. So if I leave it like this, it works, but it goes very fast. Because first of all, we need to multiply this gravity by the delta time in order to have smooth animations and to move only the distance relative to the time that passed. Now it's still a lot, and for that reason we need to decrease this by multiplying with a constant like 0.001. This is going to be like a speed, like how fast do we want this to move. Probably too much. Oh, and it works. Still the speed is too much, so I'm going to decrease it more. Save. Oh, I know. We hold it this way too long, the value goes, basically it becomes too big, and then when we come back we need to wait a lot of time for it to come. So it's not visible that the shared volume value probably became millions, but what we are interested in is to clamp it from 0 to 1. So we can say shared volume value, I don't know, like is equal to math dot maximum between shared volume value and 100, and this way we will clamp it. We need to do minimum between these two, and then maximum between that one and 0, and this way we will clamp it from 0 to 100. This one is the default, It actually shouldn't be 100, it should be 1 because we are working with 0 to 1. Yay! Now it works better. Okay, so something is working. It's actually moving based on the gravity, but it's moving in a linear way. So for the next one, like so far, I've been able to do it myself, but at this moment I wanted to check like the source code from Reanimated because they implemented this one. So they also implemented an acceleration parameter, and that gave this animation an even more realistic look. Because at the moment, if we put it this way, it will go in that direction. I can even slow it down a bit for it to move slower. So basically, if it stays like this, it moves constantly with the same speed. In a real life, the ball will actually pick up speed as it moves along, right? Because if it stays like this, it will pick up speed more until it reaches the end. This part of picking up speed is the acceleration, or how fast should the speed increase every frame. And let me try to implement it based on my math knowledge. So basically for the acceleration, we're gonna need another value. That is a volume. Our is acceleration equal use shared value 0. Now here in every frame, our acceleration should basically increase also based on the gravity. Acceleration increases based on the gravity, multiply by that time. Maybe we will need a bit more to decrease the value of this acceleration. And changing the value of our shared volume should also work based on the acceleration. So do we need the delta time here or not? No, I think we might actually need it. And we should do value. Acceleration dot value multiply by sensor value, multiply the delta time, and then the speed. I messed something up. So initially acceleration 0. We turn the phone a bit. We're not picking up based on the gravity here, but based on the acceleration. So I think we will remove the gravity from the position of the volume because that one is taken into consideration here. Should we multiply this to decrease this one as well? Oh, and I think that we have the same problem with acceleration. It increases unlimited number of time. So when we reach, if the volume reaches 0 or the volume reaches 1, then we need to reset the acceleration because we basically stopped in the wall. Does it work? If I reduce the speed, does it pick up speed? Yeah, I think it does. Slow, and here faster. Yes. Now, as you can see, when moving it like this, it behaves like an actual ball. Like it will not start moving in the other direction right away, but it will start changing the acceleration. So it actually behaves like a ball. It's just a matter of how fast you want to change the acceleration, and this will imitate like how heavy is the ball. Because right now the ball seems quite heavy, like it takes a lot of time to change the acceleration in the other direction. So if we want it 0.5, yeah, something like this. Let's have a look at the source code from Reanimated. Let's compare with this one. Specifically, I want to check the physics logic. So they have here the acceleration, which is the animated sensor. Yeah, like they are still multiplying the sensor value by a constant, like how heavy you want the ball to feel, and then multiply by delta time. Yeah, that's what they have. Then for the x, they are just simply, here, maybe I should reduce it on the acceleration side, 0.01. Okay, you need to do, it's very hard to balance this one. The ball seems to move very fast. So the acceleration changes very fast. I want to decrease this one. To decrease, we need to increase the number, right? Gravity. Okay, perfect. I like it. But you know what? The problem is that at the moment, the volume will actually not work because we are only updating the shared value. We're not updating the volume in the global state. So maybe we can also, in the use volume context, we should add a shared volume. And yeah, let's do a shared volume, which is going to be, I don't know, value 0. And let's add the shared value here, shared volume equal use shared value from Reanimated, and let's export this one from here. And in our gravity, instead of declaring the shared volume here, let's import it from use volume, shared volume, and inside our music player, let's specify how do we want to take it. Is it an animated one or a proper one? So let's say it's an animated. So in music player, we can receive this animated prop, which can be initially false, and that's going to be the shared volume. So basically const volume equal, if it's animated, it should be shared volume dot value, otherwise it should be this normal volume. Will it work? I don't know. Let me try. If I go back to the default, I just want to make sure that it works here. Come on. Okay, this one works. If I go to the gravity, we broke it. Gravity, music player is animated equal true. Then here, we're working with this shared volume. On value change should not be here, actually. Why it's not working? Shared volume coming from that one. Oh, because in the volume context, I think we should initialize it with 0. And it actually controls the volume. That was what I was worried about. But now we hooked it up, and this shared value, the position of our slider here, actually controls the volume. So I'm happy with that. Go ahead and try to implement it yourself. You can download the project, the example, the template from the description below. And also I'm gonna put the source code with everything that we did today. So if you enjoy this one, make sure to subscribe to the channel, not to miss any future videos. And yeah, bye.